Hey everyone, and welcome back to Talk Tensors. We always bring you the latest and greatest in AI research, and today is no different.
Oh yeah, we've got a real treat today.
We are diving deep into this super cool paper that really caught our eye.
It definitely stood out.
It's all about bioacoustic monitoring.
Always a hot topic.
For sure. But here's the kicker.
And it's a big one.
They actually built a working system. It's called Acoupi.
Yeah, none of that purely theoretical stuff here.
Nope. This is about taking AI right out into the field using the power of edge computing.
Exactly. Imagine instead of collecting tons of data and, lugging it all back to the lab,
Right.
you have these tiny devices analyzing animal sounds in real time.
It's like magic, but, science-based magic.
It's the best kind.
And we're going deep into the actual paper today, folks, not just some, news summary.
We're talking figures, tables, the whole shebang.
So buckle up, because this is Talk Tensors, and we're about to get our deep dive on.
What really excites me about this paper is that they went beyond just, theory and simulations.
Right.
They actually built a functional system and tested it out in the real world.
Yeah, they didn't just test it in a lab or something.
Nope. They deployed Acoupi in London's Queen Elizabeth Olympic Park.
A whole month, too.
A whole month of monitoring birds and bats.
That's impressive.
Oh, and they didn't skimp on the AI models either.
What were they using?
They used some pretty sophisticated stuff like BirdNet and BataTech 2.
Nice.
What's really fascinating is they achieved these really high recording and message delivery success rates.
So the system's pretty robust then.
It seems so. It really speaks to its robustness. But of course, there were some real-world hiccups.
Oh, I'm sure there always are.
Like when, dislodging one of the devices.
I could see that happening.
And then a software glitch with another one.
Classic.
Which they've since addressed. These real-world tests are so valuable.
Totally, because they highlight not only the potential,
but also, the areas for improvement.
It's science in action, folks.
Messy but beautiful.
Okay, before we get too far ahead of ourselves, though, let's rewind a bit and talk about why this research even matters in the first place.
Good point. Let's set the stage.
Traditional passive acoustic monitoring, Pam, can be pretty resource intensive.
Intense is an understatement.
Right.
Think about it. Researchers have to go out, collect tons of audio data, bring it back to the lab, and then spend hours, if not days, manually listening to and analyzing those recordings.
Talk about a time suck.
It's a huge bottleneck. It limits how quickly you can get insights.
It's like trying to understand a whole symphony, but only listening to one instrument at a time.
What a perfect analogy.
Right.
You're getting it, and that's where Acoupi shines. By processing data right there on the device, it eliminates the need to transfer these huge amounts of data.
Oh, that's got to be a relief.
It saves on storage.
Big time.
But most importantly, it provides near-instant insights.
So researchers can actually react to what they're hearing.
Exactly. It's a game changer for making those quick decisions in the field.
Okay, so we've established Acoupi is super cool and efficient.
Check and check.
But how does it actually work? The paper gets into the architecture.
Ah, yes, the nuts and bolts.
And it seems pretty clever.
They designed it with this idea of modularity in mind.
Modularity, okay.
Think of it like building with Legos.
I like Legos.
Right. It's essentially how Acoupi works.
Okay, I'm intrigued. Break down these Lego blocks for me.
So you've got the program layer, which acts like blueprints.
Blueprints.
Okay, provides these pre-built templates for different tasks.
Like what kind of tasks?
Well, if you want to do just basic recording, you'd use the basic program template.
Makes sense.
But if you're looking to detect specific species, you might go for the more advanced detection program.
So you can kind of customize it, depending on what you're trying to do.
Precisely. Then you have the tasks layer.
Tasks, okay.
This is where you define what actions you actually want the device to take.
Like record audio.
Exactly. Things like recording audio, processing it, sending messages, and so on.
So it's like programming a little robot to go out and listen for you.
You got it. And then there are components. These are like the individual Lego bricks.
Okay, the building block.
These are reusable bits of code that make up each task.
Got it.
And the beauty is you don't need to be a coding whiz to put them together.
That's a relief.
Finally, you've got the data schema.
Data schema.
Think of this as the instruction manual ensuring all your Lego bricks fit together perfectly.
So everything works smoothly.
Exactly. This guarantees consistent data flow throughout your program.
Okay.
Which makes collaborating and sharing your work with others a lot easier.
So basically, Acoupi is like a bioacoustic Swiss Army knife.
I love that.
Adaptable, flexible, and powerful.
You nailed it.
All right, it's time for our favorite part of the show.
Yeah.
You know what's coming.
Novel notions time.
That's right, novel notions. We've seen how Acoupi is like revolutionizing bioacoustic monitoring.
Totally changing the game.
But what about pushing it beyond just animals?
Oh, I like where you're going with this. Remember how we were talking about the importance of edge computing?
Yeah, for those real-time insights.
Exactly. What if we could use Acoupi to create like an early warning system for natural disasters?
Well, hold on. You're saying we could use it to like predict earthquakes or tornadoes?
Think about the sounds those events make, the rumbling of the earth, the roar of a tornado.
Yeah, okay.
What if we could train AI models to recognize those unique sounds, those signatures?
I see where you're going with this.
Acoupi deployed in disaster-prone areas could potentially detect these sounds early on
And then?
and then send out alerts, giving people precious time to prepare or evacuate.
That's an incredible idea. Talk about real-world impact.
Right. And it's not just about reacting to disasters.
What else?
We could use this data to better understand these events and potentially even predict them more accurately.
So it's not just about responding, it's about understanding.
Exactly. Turning passive listening into proactive action.
I like that. Okay, so we've got disaster prediction, but you were about to say something else.
Oh, right. We focused on animal sounds so far.
Makes sense, bioacoustics and all.
But what about the sounds of our urban environments?
Okay, getting a little meta here.
What if we could use Acoupi to monitor the health of our cities?
Interesting. What kind of sounds would we be listening for? The honking of cars, the rumble of construction.
Well, those are part of it for sure, but think about the more subtle sounds that might indicate problems.
Subtle sounds okay.
Things like the creaking of aging infrastructure.
Oh, like bridges and stuff?
Yeah, or the hissing of gas leaks, even changes in traffic patterns that could signal congestion or accidents.
So a Acoupi could be like a city doctor, listening for those telltale signs of trouble.
Precisely, imagine a network of these devices throughout a city, constantly monitoring the acoustic environment.
Always listening.
Alerting authorities to potential issues before they escalate.
We could create safer, more efficient cities just by listening.
It's a powerful idea.
It really is. This whole conversation's got me thinking about sound itself,
What about it?
It's such a fundamental part of our experience, yet we often take it for granted.
Absolutely. Sound connects us to the world around us in ways we don't even realize.
And with tools like Acoupi, we're starting to tap into its true potential.
We're just scratching the surface.
Okay, before we get too philosophical here,
Right back to the paper.
we've covered a lot of ground today.
We have, from the technical details of Acoupi's architecture to its potential for revolutionizing bioacoustic monitoring.
And even expanding into new areas like disaster prediction and urban health.
It's been a whirlwind.
It has, but it's important to remember that all of this is based on, solid research.
This is the real deal. We've been diving deep into an actual academic paper, not just some, surface level stuff.
Exactly. This is cutting-edge science in action.
And speaking of action.
Yes. Let's talk about how this research impacts those of us who aren't scientists or engineers.
Right. Why should the average person care about a tool like Acoupi?
That's a great question, and it really gets to the heart of why we do this podcast.
We believe that everyone, regardless of their background, should have access to the latest scientific discoveries.
And understand how they impact our world.
Science isn't just something that happens in labs and universities.
It's all around us, shaping our lives in countless ways.
Exactly. And Acoupi is a perfect example of how seemingly niche research can have ripple effects across society.
Like those ripple effects.
Think about the potential for those early warning systems for natural disasters that could literally save lives.
Right. Or the possibility of using Acoupi to create safer, more efficient cities.
These are things that impact everyone.
And beyond those practical applications, there's something really profound about being able to listen to the world around us in new ways.
You're right to hear those subtle sounds that often go unnoticed.
It's like expanding our senses, deepening our connection to nature and to each other.
Beautifully said. It's about recognizing that we're all part of this complex, interconnected ecosystem.
And that even the smallest sounds can tell us incredible stories.
You really can.
Okay, I'm feeling inspired, but before we get too carried away,
Right.
let's focus on the present and talk about what Acoupi means for researchers working in the field right now.
Good idea. How is it changing the game of bioacoustic monitoring?
Well, one of the biggest impacts, I think, is accessibility.
Oh, absolutely. Traditionally, setting up a PIM system required specialized equipment, technical expertise, and a lot of money.
It was a barrier to entry for sure.
Acoupi, with its open source software and affordable hardware, is making this type of research much more accessible.
So now anyone with a passion for nature and a bit of tech savvy can contribute to scientific research.
Exactly. It's empowering citizen scientists, students, and researchers in developing countries to participate in bioacoustic monitoring.
It's like democratizing science.
I love that, giving everyone a chance to explore and discover.
But it's not just about access, right?
No, it's also streamlining the research process itself.
Right. Remember that traditional workflow?
Oh, yeah. Deploying recording devices, manually retrieving data, spending countless hours annotating and analyzing recordings.
Talk about a time suck.
It was a tedious process. Acoupi eliminates a lot of that tedium.
Thank goodness.
The on-device processing means researchers can get near-instant insights from the data.
So they can refine their methods, make adjustments, and ultimately make discoveries much faster.
It's like having a constant stream of data flowing in, revealing the hidden secrets of the natural world in real time.
And it's not just about speed, it's about quality too.
Oh, for sure. By reducing the need for manual annotation, Acoupi minimizes human error.
Which is always a good thing.
It increases the consistency and reliability of the data.
So researchers can spend less time wrestling with spreadsheets and more time doing what they love.
Asking questions, making observations, and uncovering those mysteries of the natural world.
Exactly. And that's what makes Acoupi such a powerful tool. It's not just a technical innovation, it's a catalyst for scientific discovery.
Couldn't have said it better myself.
Okay, I'm officially a fan. But before we wrap up this deep dive, I think we need to take a moment to appreciate the journey that led us to this point.
You're right. The history of bioacoustics is fascinating.
It's amazing to see how far we've come.
You know, I'm a big believer in understanding the past to appreciate the present.
Totally agree.
The story of how we learn to listen to nature is full of ingenuity, perseverance, and a deep fascination with the world around us.
All right, let's take that trip down memory lane. When did humans first start paying attention to the sounds of nature?
I mean, it's not like we just started listening yesterday.
Exactly.
Our ancestors have been listening to the sounds of nature for millennia.
Way before recorded history.
Think about the role of animal vocalizations in hunting gathering and even early forms of communication.
It was essential for survival.
They were attuned to the sounds of their environment. It was like nature's own alarm system, warning them of danger or guiding them to food.
Right, but when did we start moving beyond just listening for survival and actually studying those sounds in a scientific way?
That's a great question. It really highlights the evolution of bioacoustics. For centuries, our understanding of animal sounds was based on observation and folklore.
Word of mouth, basically.
But then in the 19th century, something remarkable happened. The invention of sound recording technology.
Ah, the good old phonograph. I bet those early recordings were pretty rough.
They were, but they were revolutionary nonetheless.
How so?
Suddenly, we could capture and preserve those fleeting sounds of nature.
Like catching a butterfly.
Analyze them in detail and share them with others. It was like opening a new chapter in our relationship with the natural world.
So who are these early pioneers of bioacoustics? What were they listening to?
Imagine explorers setting foot on a new continent for the first time. These early bioacousticians were venturing into a vast, uncharted territory, the world of sound. They were recording birdsong, whale calls, insect chirps, anything that made a noise.
It must have been like trying to decipher a new language.
Exactly, and back then, they didn't have fancy computer programs to help them. It was all about manual annotation and painstaking analysis. But as technology advanced, so did our tools for studying sound. We developed spectrograms, which allowed us to visualize sound frequencies over time, revealing hidden patterns and complexities.
So we could actually see the music of nature.
Exactly. And then came the digital revolution, which completely transformed the field of bioacoustics. We could now store vast amounts of data, digitally process it with computers, and develop algorithms to automate analysis tasks.
Which brings us to the age of AI and the incredible power of tools like Acoupi.
Full circle.
It's amazing to think that those early recordings of birdsong on wax cylinders paved the way for the sophisticated technology that's changing the way we listen to and understand the world around us.
It's quite the journey, isn't it? And it's a reminder that scientific progress is often built on the foundations laid by those who came before us.
Well said. So we've explored the past, we've delved into the present.
What's next?
Now it's time to look towards the future. What are some of the emerging trends and challenges in bioacoustics that you're most excited about?
Well, one trend that's really catching my eye is the increasing integration of bioacoustics with other fields like ecology conservation and even urban planning.
So bioacoustics is breaking out of its silo.
Exactly. As we gather more data about the sounds of nature and our built environments, we're starting to see how this information can be used to address a wide range of challenges.
Give me an example. How is bioacoustics being used in unexpected ways?
For instance, some researchers are using sound recordings to monitor the effectiveness of habitat restoration projects.
Habitat restoration, okay.
By analyzing the soundscape before and after a restoration effort, they can track changes in biodiversity and assess the overall health of the ecosystem.
So it's like using sound as a measure of ecological recovery.
Precisely.
What about in urban environments? How is bioacoustics being applied in cities?
Well, one really interesting application is noise pollution monitoring and mitigation.
Noise pollution, that's a big one.
By placing acoustic sensors throughout a city, researchers can pinpoint the sources of noise pollution and develop strategies to reduce its impact on human health and well-being.
So we're not just listening to nature anymore. We're listening to the sounds of our own creations.
Exactly. And as our cities become increasingly noisy and crowded, understanding and managing urban soundscapes will be crucial for creating livable and sustainable environments.
It's like we're composing the symphony of the future, one sound at a time.
I love that analogy.
Okay, so we've got all this incredible data about the sounds of our world, but what do we do with it?
Right. How do we translate this acoustic information into meaningful action?
That's the million-dollar question.
And it's where the real magic happens. It's about connecting the dots, finding patterns, and using those insights to make informed decisions. Whether it's protecting endangered species, restoring damaged ecosystems, or designing quieter cities, bioacoustics is giving us the tools to listen, learn, and act.
It's like we're finally tuning in to the whispers of our planet, understanding its rhythms, and working in harmony with its soundscape.
Beautifully put. And with tools like Acoupi, the symphony of our world is becoming clearer than ever before.
Okay, so we've journeyed from the nitty-gritty of this paper's tech all the way to dreaming up Acoupi on Mars. But let's circle back to Talk Tensor's roots, analyzing the research itself.
Right. It's easy to get lost in those what-ifs, but this paper is strong because it's not just a concept. The researchers actually built Acoupi, deployed it, got data that's a level of real-world testing we love to see.
And they're honest about the hiccups, too. The wind incident, the software bug. It reminds us that science isn't always a smooth lab experiment.
Exactly. And their openness makes the findings even more credible. They fixed that bug. They're improving the system. That's the scientific process in action.
Which brings us to one of my favorite aspects of Acoupi is open source. This isn't some company's secret sauce. It's a collaboration waiting to happen.
That's huge for the field. Open source accelerates everything. More people can build on it, adapt it. The possibilities multiply way faster.
Imagine a global network of Acoupi users, all contributing data, refining the system. We could be on the verge of a bioacoustic data explosion.
It's not just about quantity, though. By automating so much of the analysis, Acoupi increases the quality and consistency of the data, too. Less human error, more reliable results.
So researchers can focus on the big questions, not getting bogged down in tedious tasks. They can react to findings in real time, adjust their approach. It's a more dynamic way of doing science.
Couldn't agree more. Now, I know we've mainly focused on the science, but for our listeners who might be thinking, cool, but does this affect me? Let's connect some dots.
Okay, bring on the real-world implications.
Well, the disaster prediction potential is huge. Imagine getting an alert on your phone that a wildfire is approaching. Thanks to Acoupi picking up the sound signature early on, that's life-saving stuff.
And the urban applications, quieter cities, early detection of infrastructure issues, this tech could literally shape the environment we live in.
And even beyond that, the deeper understanding of biodiversity, it impacts everyone. Healthy ecosystems are vital, whether we realize it or not. Acoupi helps us protect those systems, which ultimately benefits us all.
So while this paper might seem hyper-specific, at first its impact ripples outward. It's a reminder that even seemingly niche research can have surprising consequences for everyone.
Absolutely. And on that note, we'll wrap up this Talk Tensors deep dive. Remember, we always link to the full paper for those who want to go even further down the rabbit hole.
It's been an incredible journey exploring Acoupi, from its clever design to its real-world testing, and of course, dreaming up those novel notions. This is research that truly excites us.
And as always, we hope it sparked some excitement for our listeners too. Keep those ears open, keep learning, and who knows, maybe you'll be the one dreaming up the next big application for Acoupi.
Until next time, keep those novel notions flowing, and we'll see you back here for another deep dive into the world of AI research.